Okay everybody, welcome back to part 2 of our video here on modules. And to start off here, I just want to review what we talked about in the first video. We talked about the fact that a module is defined as a group of statements that exist within a program for the purpose of performing a specific task. When you create a module, you usually want it to do one thing in particular. You give it the name of the task that it's going to perform. So this module, this group of statements, when you create it, you write its definition, which basically consists of a header where you name the module, and then the body where you actually write the code that runs when the module gets executed. We talked about the fact that doing a module has many benefits. One of them is the fact that the code is simpler. That's because you can structure your code to push all of the details into the modules. So if you think about your program when you run it, you can just simply call a bunch of modules. So the program actually may consist of 5 or 6 calls out to various modules, and if you just look at the names of the modules, you can kind of see what it's doing at a very high level, and all those details are abstracted down into the modules. It just makes the program a little simpler to understand and to read. The second big benefit here is code reuse, and we really looked at that a little bit. You'll see in the example here that I'm going to show you how it makes code reuse possible. But whenever you have code that's duplicated in your program, usually you can put that duplicated code into a module and just call it wherever you need it. That's one of the primary benefits of a module, is code reuse. Better testing simply means that you can take a module and you can test it on its own, independent from anything else. And so if you think of a module as a component, you can test that component on its own to make sure that it's solid and robust before you plug it into the rest of the program. Faster development, what that simply means is if you break your program up into a series of modules, you can assign your development team different modules, and they can all work in parallel with one another. And then as the modules get completed, you can then integrate them together. So in theory, you can have a faster turnaround time in development because of the fact that you are working in parallel on different tasks that, generally speaking, don't interrupt one another or interfere with one another. Then the last point there, easier facilitation of teamwork. If every team member is working on their own module, it just makes the whole interaction on the team much easier. Because again, you're not getting in each other's way, you're not both trying to write code to the same file. It just separates things out in a way that makes everything easier. So a module has many, many benefits. Now, one of the types of modules that you can create, and that's really what they focus on in this chapter, is a certain type of a module called a procedure. And a procedure is a block of code that runs, and a procedure actually can be further broken down into either a function or a subroutine. A subroutine runs code and never returns anything back to you. A function is geared to give you something back. So for example, if you had a function called calculate area, the function may return the area back to you. On the other hand, if you had a subroutine called calculate area, it wouldn't pass the area back to you. It wouldn't be able to do that. Instead, it would have to set a variable that was global. Which brings me to the next point, variables. A variable declared within a module is private to that module. Now, in FreeBasic, we don't declare variables. If you need to use a variable, you just type it in and start using it. But in most programming languages, if you want to use a variable, you have to define it first. Let me show you what I'm talking about. Let's say that you wanted to ask somebody their age. Now in small basic, we would say age equals text window dot read number. And then we would say text window dot write line. Actually, we wouldn't use write line, we would just use write. And we would say, what is your age? Now, with most languages, what you have to do is declare your variable first. So for example here, in this particular example, declare age as integer. You're basically telling the compiler that you are introducing a new variable into your program called age, and that it's an integer. Now, in small basic, you don't have to do that. So you might be wondering, why? Why would you want to go through the trouble of doing that line 3 there if you don't really need to? Because after all, small basic doesn't force you to do that. Well, this is the reason why programming languages force you to declare variables. If you were to come down and misspell the word age, so for instance here you have AGE, and let's say that you accidentally hit the S. Now, the variable is not spelled right, and it is an error in the program. In small basic, what will happen is it'll see AGS and say, oh, I haven't seen you before. You must be a variable that's brand new. So I'm going to go ahead and create you and put you in memory. The problem is you would now have two variables, an AGE and an AGS. And more than likely, the rest of the program would be dealing with AGE. So the result is you'd be reading in a number from the user and storing it into AGS, and then never touching it again. Meanwhile, AGE would never have been set because of the typo. Now, in a declarative language, what would happen here is you'd get a syntax error. It would say, sorry, you can't use AGS because you haven't declared it yet. You would have to actually come up here and declare it like that. Well, you wouldn't do that obviously here because that's a typo. But it points out to you the importance and really the benefit of declaring variables before you use them. So then you might be asking, if that's such a big deal, then why does small basic not require you to do it? Well, the answer to that quite simply is they don't want to have you write more code than you should have to. They want to simplify, simplify, simplify all the time. And so the trade-off, if you don't have to declare a variable, it's kind of nice, right? You just, when you use it, when you want to make a new variable, you just type it in, start using it. So it makes it easier. But whenever you make something easier, you sacrifice something else. And in programming, in a language, when you make things easier for the programmer, you open up the potential for logical errors. And logical errors, such as this one right here where you put AGS, logical errors are very difficult to pinpoint and track down. That trade-off is generally not worth it in most industry-wide, industry-established languages. So I just want to make you aware of that, because when you guys take programming courses beyond this one and go into languages like C# and Java and so forth, you're going to be required to declare those variables first. And so I just want you to be aware of that. And in the book, it will talk about declaring variables, and that's because most languages require you to do so. So, okay, enough about that. In the first part of this two-part series of videos here, this is the program that I built. I set up a program to ask the user the area of their yard, and then I asked them questions about the area of their driveway and their patio and their house and other things, and I subtracted those out so that I would give them a number, which would be the area of everything that needs to be fertilized in their yard. Well, to do that, I started out by asking them for the dimensions of the entire yard, and I stored that into a variable. And I stored it into another variable called fertilized area. So I have yard area and fertilized area. And then what I do is I start asking them questions like, what's the length and width of the house? And then I calculate the area of the house with those two values. Then I take the area of the house and I subtract that from the fertilized area variable, which decreases the value of fertilized area because I'm pulling away different pieces that don't need to be fertilized. I do the same thing with the driveway and with the patio and the shed. But notice here, it's the same process every single time. This is a prime case for the use of a module. So let me show you the alternative to writing it this way, and that is this approach. Now let me run this first before I go into the details of it, just so you can see how it works, okay? First it tells them what the program is going to do. Okay, then it says, let's start with the dimensions of the entire yard. So you enter your dimensions. Then it says, great, now let's deduct the area of the house. So you put in the area of your house, the area of your driveway. Whoops, I screwed up. Oh well. Area of the patio, and then the storage shed. Okay, and it gives you the answer, area to fertilize, and then the square footage that you see there is the yard minus all of those things that don't need to be fertilized. So the program in this newer and improved version works exactly the same way as the first one did, but notice the way I've structured it. To start with, at the top, I put in my comment block. This is something you should all be doing when you write your programs as assignments. You start with a block of comments where you put the title of the program, who wrote it, when they wrote it, and then a description of what the program is going to do. Now, in my program, I start out by initializing my total area to 0. I tell them what I'm going to do. Notice these comments. I get the starting area. Then I remove the house, remove the driveway, remove the patio, remove the shed, and I display the results to the user. Notice, in every one of these blocks, I'm printing out something to the screen, and then I'm calling the adjust area subroutine. So for instance here, I say let's start with the dimensions of the entire yard, and I call adjust area. Then I say let's deduct the house, and I call adjust area. And every time I call this adjust area subroutine, it is doing something for me. Well, what is it doing? Let's take a look. This is my subroutine. Notice I have a little description here of what it does. In Small Basic, you start with the word sub, and then the name of the subroutine, and then an end sub at the bottom. Notice there's no space between the end and the sub. Inside the subroutine, I tell them to enter the length. Notice I don't say the length of what. I keep it generic. I just say length. And then I say enter the width. Again, I don't get specific. I have a variable called length and one called width. Then I create one called area, which is length times width. Now here's the little trick, and this little trick here, we haven't talked about decision making yet. That doesn't come up until next chapter, but it's pretty easy to understand, so I'm going to go ahead with this anyway. If the total area, meaning the area of the yard, is equal to 0, and what that basically means, if the total area is 0, that simply means that it hasn't been calculated yet. And that would be the case the first time into this subroutine. And if that's the case, it takes the area that it just calculated and sets it equal to total area. So the very first time I call adjust area, if I go back up in my code here, the first time I call it, I'm asking for the dimensions of the entire yard. The first time I call it, it gets the length and width, it calculates the area. The total area will be 0. So it will set the area that it calculated into total area. The result will be, when it comes out of this subroutine, is that the total area will be set. Now the next time I call adjust area, I'm going to have said, great, now let's deduct the area of the house. Notice the user will see the word house. And immediately following that, it's going to call adjust area, which prompts them for a length and a width. Well, length and width of what? It'll be of the house, because I just told them that that's what we're going to be dealing with. They enter the numbers, we get an area in line 53. In this case, the total area will not be 0, so it will skip this and come down and do this stuff here. In this case, it'll set the total area equal to itself minus the area. When you look at statement 57 here, go and look at the right-hand side first and then look at the left side. What it's doing is it's taking the area, which is of the yard initially, and subtracting the area of the driveway in our case, the first time through, after the initial run through. So it's reducing total area. Whatever that subtraction results as, it's putting it back into total area. So total area is constantly being adjusted downward as you're putting in more data. The trick here is that this subroutine is entirely generic. And in my code above this, I put the specific information first in a statement, and then I call the subroutine. And by doing it this way, I'm able to reuse the code inside of adjust area and make my program much shorter and simpler than it otherwise would be. Now, I'm going to put this example out there along with the first one so that you all can see these and you can compare these. But this is an example of how a subroutine can reduce code duplication. Now, I'm still duplicating code. Line 22, 26, 30, 34, and 38 are all the same. But all they're doing is calling the same procedure. So yes, it's duplicated, but that's really not a big deal because I really won't have to change any of this. Let's say that I needed to change something in adjust area. For instance, maybe I need to take the area equals length times width, and maybe I need to subtract 20% more, 10% more, let's say. In other words, I may have to fiddle around with line 53. If I had duplicated this code 4 times, I would have had to make that change 4 times. But because it's in a subroutine now, if I need to change anything, I only have to fix it or change it once. Only once, instead of all the times that it's being called. If I had it up here 4 times, duplicated code, and I forgot to change one of the 4, then I would have another bug in my code. So this is why it also helps as far as like eliminating potential bugs in code, because there's only ever one copy of something. So if you have 5 copies of something and you need to change something inside of each copy, well, then you have to change it 5 times. But if you call one thing 5 times, but you only have one thing that you're calling in all 5 cases, that one thing, you can just change it and you're good to go. And so that's another real benefit of subroutines and functions. So that's it for this series. I just wanted to show you the 2 programs, compare them a little bit so you can get a sense of why subroutines and functions are valuable. Now, in Small Basic, you can't write functions. You can only write subroutines. In another lesson or 2 down the road, I'm going to show you a few other languages. And we'll come back to this modules topic, and I'll actually show you how to write a subroutine and a function, and some of the things that are talked about in the Gaddis book. We'll get into those in some different languages when the time is right to do that. For now, I'm going to call it good here and get this video out to you guys so you can watch this. So I hope you found this helpful. As always, if you have any questions, let me know. The code for these 2 examples will be in the link where the video is. I'll put it right near that so you'll be able to pull these down and look at them and try them out. So thanks for watching, and we'll see you in the next video. Take care.